Welcome to this technology demonstration featuring Autodesk Manufacturing Technology at Work. In this example, the design team has been challenged to increase throughput of this robotic welding station. Not only will their customer benefit from being able to produce more, the manufacturer could increase market share by offering better performing products, lower overall material and production costs through reduction of material used in design. One significant difference you'll see during the demonstration is the idea of predictive versus iterative design. Autodesk's shape generator technology enables engineers to define form based on the function that a component will perform. Let's have a look. As a project manager, I must begin a collaborated effort across several groups in an efficient manner. Autodesk technology provides a tool where engineers can collaborate not just on their data, but manage processes as well. Vault provides a centralized database where all the files can be stored and accessed. This way, we know everyone's working on the right information. I've already started an engineering change order in the Vault. We can see the reference documents are already attached and easy to find. And we can preview the email without needing to open any files. Let's be sure to include a requirement that was emailed to me. Opening the file, I can see that it's a markup, a powerful way to visually share the changes required and eliminating communication errors. Now, using the Outlook integration, the markup can be checked in, ensuring all of our project documents are found in the Vault. As the acting design engineer, I can begin by looking to my work list at an engineering change order. It contains attachments relevant to the design problem at hand. Today is a lightweighting exercise intended to increase the cycle time in this customer's tooling assembly. Once we have determined which functional area of the assembly will be affected by this change, the Vault's search tools enable us to quickly locate and isolate those resources. Copy design makes quick work of duplicating entire assemblies, and custom numbering schemes can be tailored to match almost any naming convention. In the Vault, users can easily visualize assembly structure, as well as highlighting parent-child relationships in a single, easily understood display. With the new assembly open in Inventor, it's time to perform some low-level engineering design tasks. Addressing the problem of determining how powerful an actuator needs to be to deliver the clamping force requested by the customer. Fortunately, Force Effect delivers just this type of functionality. What could easily be described as an automated, free body diagram tool, Force Effect enables us to reduce our design problem down to its essential mechanical elements, and then predict the viability of our design concept. Force Effect provides intuitive interaction for drawing, constraining, and simulating concepts. Diagram elements are easily selected, then manipulated. Also provided is a robust selection of joints, supports, and loads. That way, any mechanical concept can quickly be created and its performance analyzed. As it is now mechanically fully defined, the sketch is evaluated in real time and shown to be in a state of equilibrium. Forces are now added, in this case our 300 Newton normal force, and then an unknown force is used to determine what force will be required by the actuator. Reports generated display all the relevant mechanical information and can easily be attached to the parent model. As a longtime Autodesk customer, Parker Hannifin's cylinder division has created an online configurator. This enables their customers to quickly create hydraulic cylinders for any of their medium-duty applications. By entering data specific to the cylinder required, the PCS configurator customizes a cylinder assembly from literally hundreds of possible combinations. The user is then given the option to have that data delivered in many different file formats, including a native Inventor assembly. One of the newer Autodesk tools available is something truly revolutionary. It's called Shape Generator. This approach to design moves powerful analytic tools to the front of the design process, as opposed to where they traditionally used to sit. This workflow enables users to drive initial design intelligently, as a function of the physical constraints and loads that the design will be exposed to, as well as density, elastic modulus, and other properties of the material being used. Once the initial shape is defined, environment variables such as fixed, grounded, pin joints, or frictionless sliding constraints are added. Subsequently, loads such as forces, pressures, moments, or bearing loads can be applied. Preserve regions may exclude zones where the material must not be removed. In this example, these areas where the pivot joint, the hydraulic cylinder, and clamp end are mounted. Finally, a mass removal target is defined and the shape generator solver starts. This new technique promises to transform design productivity in ways not previously possible, as initial model shape is defined primarily by the demands of the physical environment that the part will operate in. This generative shape is then merged with the initial model volume, and then any number of modeling techniques can be used to remove that material from the volume, leaving the minimum amount of material required to match the shape defined by Shape Generator. In this case, traditional sketch volumes are created and used to remove the bulk of the material not needed. Direct modeling and freeform tools may also be used depending on the complexity of the part and the shape of the areas that need to be removed. Fillets are added for blending purposes, and finally, the part is saved and checked into the vault with the rest of the new clamp assembly. The shape generator process was also used on the main clamp backplate, and here we use Inventor's replace component functionality to swap the new for the old. Finally, these changes are driven down the assembly and all existing instances are updated to the new configuration. Now it's time to make sure that the new design is going to last for the life of the ASCA welding fixture. We can do this right in the CAD design environment. We can even use the boundary conditions from the Shape Generator study to save time and ensure consistency. In the browser, there's a bearing load from the actuator, as well as two constraints simulating the pin and contact with the automotive component. The material also comes over automatically and can be used for the virtual test. We could run a linear static study and simply test for stress and displacement. But that's not going to be enough. We need to know if the clamp can withstand 300,000 load cycles. This requires fatigue calculations. There are numerous ways to constrain and specify boundary conditions. In this model, we have a hole that can only rotate along its axis. We know that there is a fastener connecting the part to the hinge plate. With the use of rigid connectors, we then have full control over the geometry. Turn on and off the ability to move or rotate any of the 6 degrees of freedom to simulate a pin or spherical constraint. Let's also make a change to the load. Fatigue results are based on the behavior of the actuator force on the clamp. Is it loaded or unloaded? Does the load reverse in the other direction? The actuator in this case only applies the load in one direction. These load curves are fully customizable for any load condition. Finally, let's mesh the part or break it up into smaller pieces to be analyzed, and run the study, which only takes a few seconds to calculate on this component. Taking a look at stress, we can see the value is very low. Shape Generator did a great job finding the best possible geometry for a lightweight component. We can also see the fatigue results show there is 0 damage over the life of the part. Is it possible we can make it even lighter? Why not try different material types, even plastic? Nonlinear studies are extremely powerful. They provide high-fidelity results for all material types, including plastics, rubber, foam, and more. Let's edit the material we used in the previous fatigue study and change it to UHMW. We will find out how much of the load it will handle before it yields, or maybe even buckles. Nonlinear studies are highly accurate. We will spread out the load in 30 increments and observe the results as it is gradually applied. We will also increase the load to ensure that our safety factor is at least 2. Unlike linear studies, we can watch the behavior of the part as the load is applied. Watch as the stiffness of the model changes and may even cause the part to buckle. This is something you will also never find in linear static results. They only tell you if the material is going to pass or yield. Find out more about your design with fatigue, nonlinear, vibration, and thermal heat transfer, all within the CAD design environment. Even check the displacement of the model while the analysis is still running. We can see here that the part does in fact buckle at 1600 newtons. This does not satisfy our requirements of 2 times the normal load condition. Animations of the results may help to understand the weak points and design changes that need to be made to the model. We know that the design becomes unstable at 1600 newtons. By watching the animations, we can make better informed decisions about improvements of our geometry. Based on these results, we can confidently move forward with the model using mild steel. Using these types of studies, we can fully understand our design and run several what-if scenarios with various materials. Now let's check in the design with a message for the rest of the engineering team. From here, the engineering change order can be approved and released to manufacturing. Autodesk provides the technology for simulation-driven modeling using Shape Generator. Also validate parts and assemblies at any point right in the context of the CAD design environment, using robust solvers for various types of studies, and manage it all in a secure and collaborative environment. Autodesk is your trusted solution. It is the future of making things.